9 years ago in Tokyo. And that was actually the conference that introduced, AutoZone introduced the adaptive platform. Now it's called AutoZone adaptive platform. And then the lead from the BMW described the concept of the adaptive. Then many of the technological elements that's discussed there was quite relevant to us. We do, well, by the way, my company name is eSOL. We are Tokyo-based embedded software company, about 500 people. I'm the CDO and the head of software to the company. And after the talk, I just ran into the BMW guy and said, okay, we have these expertise, and are you interested in us joining? And he said, of course. Then that's how we became a permanent partner. Then I first went into the operating system work group. Then soon after, the AutoZone adaptive actually didn't have an architecture group. So I proposed to PLs to have a task force with a dedicated expert architects with like 4 people. And then we started this task force architecture, and I led this group in the first years of adaptive. So it's AOC is made a big change in personally and also company-wise, and hopefully to some extent contributed to the AutoZone. So I'm really glad to be back here. The AOC is back here in Tokyo, that I have a chance to talk to you today. So my topic is about quite bold, very unusual Japanese for Japanese. The 4 principles of SDV. Why it's bold? Because many people still wonder what SDV is, and now I'm talking about the principles of SDV, or how come, right? So let's see what I got. So first I will talk briefly about the definition of SDV. Instead of me coming up with my original definition of SDV, I just quoted some of the experts say in the field. Like says, well, upgrading a car is one of the key terms. Active said the hardware-based to software-centric. This one from IBM separates hardware from software, updatable, upgradable, autonomous learning, interacts with its environment, supports service-based business. Gartner said upgraded over time, fundamentally by software. And finally, the Morris from the electric, who actually was one of my task force in our years of adaptive, and talks about the delivering values through software, decoupling and deliver new values through software again, and capture the value. So if I summarize it, it becomes like on the left side. It's quite hard to see like this, because I don't have any stickers. So SDV is deeply defined by software, and it has both business and technical perspectives. Talking about the business, they are talking about new values through software, capturing the values for service-based business models. On the technical side, software-centric separates hardware from software, upgraded, that kind of combination. Okay, but still fuzzy, right? Why it's fuzzy? Because CV is new. And it's like new, when you design a new system or a new software system, of course, from the V model, you should start with the specifying requirements. But you know, you all engineers know, just starting with requirements is just not possible without diving a little bit into the design, a little bit into the variable product demo development. Then you come back up to requirement because you get a better understanding of what you can do, and also understanding the space of the requirements that you are facing. So my approach here is that I like to dive into the principles of how to realize SDV, and which hopefully clarifies the definition of SDV. So 4 principles I came up here is these. First one is about non-automotive domain modeling. I will come down to the detail in the next slides. But the big point is I'm not talking about automotive domains like ADAS, powertrain, chassis, IDI. That's not the domain I'm talking about. So it's non-automotive domain. Second one is decoupling. And decoupling in many different planes or different senses. Like one example is between hardware and software, The other is mission critical and non-mission critical. My software and your software, or application and platform. All these different types of decoupling that we need. Third one is open standards. Because we need to make technology accessible to different stakeholders and to the market. And this is actually essential for software reuse, and also from a regulation or compliance point of view. Last one, democratization. This is basically enable software developers who are not automotive experts at all, unlike us that, well, supposed to be automotive experts, and enable those developers to program a car to enable, in a way, most programmable vehicle on the planet. So, and each principle are not independent, they actually interdisciplinary and supports each other. So, talking about non-mobility, well, this is actually not that difficult because in the keynote yesterday by Lee from Google by Toyota, it's by the way a good friend of mine, talked about hardware-defined vehicle, right? And now we are talking about software-defined vehicle. It's a vehicle defined by software, okay? But how do you create or design this software? That's a big question. Because how you used to design software before or up to now is like, oh, okay, I need to do the ADAS. Or I need to put these cell cameras in. Or maybe these lidars in, or ADAS in. Okay, you start from hardware bottom up and design, abstraction your devices, then to your algorithms. But mostly directly accessing these hardware device drivers, all tightly possible. Not decoupled, right? So, well, you cannot do that because that's how you define it. Okay, how do you design this then? Well, actually, you need to start from the top down. You need to look at the vehicle system from the top level, and you need some kind of model to describe the holistic vehicle system. I'm not talking about just the vehicle itself, but everything, the world of the vehicle, let's say. So that's the model we need. And the one I picked is this one, which is not my original concept or anything. It's actually in many previous studies in research for decades actually, and it's called DVE. D stands for driver, V stands for vehicle, E stands for environment. And actually, you need some other utility stuff. That's why I call this a DVE plus U. U stands for utilities. And the first, if you do academic research, you can find one of the first instances of the use of the term DVE comes up in 2006, almost 20 years ago. This happens to be a Japanese professor who's retired right now. But there are many instances of the concept of the model DVE in many cognitive science, psychological studies of the people, the drivers, human drivers, ADAS, safety, and also like HMI, like adaptive HMI, kind of next generation HMI that adapts to the driver's needs, each different personal driver's needs. They basically discuss their approaches based on DVE. So that seems to be a good story. This is a picture that I used often in the past AOC. We don't have that this time, this AOC, but in the past AOC, we always used to have an introduction session of AutoZ Classic and another for the adaptive, about 50, 60 minutes. And I used to run this kind of training session. And this is one of the slides that I used to use. So you can see from the left crowd, IDI payment, you call brain or central whatever, which runs on adaptive. On the right-hand side, you have classic platform. And of course, real-time requirements gets harder when you actually go from right to left. So that's what, and underneath you have a hardware. Now we are talking about more of a multiple nodes of heterogeneous many kind of hardware. And the layering, it's kind of small. Is from the bottom you have hardware, operating system layer. I got this foundation layer. Also I call it classic platform, adaptive platform. They are not really that high level platform in my point of view based on service-oriented architecture. It's actually a foundation layer to enable the platform. Then you have a service layer because it's service-oriented architecture. These are the what kind of characterizes the virtual instance of the platform. So what kind of service you have here is what basically defines what the platform is. And then you have application layer. And I used to have these services, although I always had this idea of DBE, I never shared this until today with anyone. But I had this idea for like 4 years, but I never talked to anyone. And I just said that these rigorous stuff that you might often see in the different technical papers from different multiple companies. And then, so that's the layer that defines the SDV platform API. And coming back to the DBE, okay, what kind of services it breaks down into? This is one, let's say take this as one proposal, although we are doing some proof of concept development on these. In the driver domain, you can have a behavior model. That's a behavior model of driver. That could be fully rule-based behavior model, like many of the ADAS systems today uses, or could be you could go fussy and use transformer to model the driver, or you could use some kind of hidden Markov model or dynamic agent, or kind of behavior model, some kind of probabilistic. And then the other is a psychological model. To be honest, I don't know. I'm not too sure yet at this point how accurate the psychological model technical work as of today's technology, affordable technologies. But it will in the future, and it's probably important to understand the psychological nature of the driver, or the participants, or the passengers. Then you have people, you have motion, interior, exterior, vehicle dashboard. Vehicle dashboard is more of a, well, literally a software dashboard to get the status of the vehicle and so forth. And this motion service is essentially, oh, by the way, this is not data level that I'm talking about. These are actionable objects. So with this motion service, you can actually move the vehicle, you can stop the vehicle, you can steer the vehicle. And then the behavior model service can drive the car on behalf of the driver, or can run in shadow mode and see where the actual human driver intends in the next seconds. And the behavior model or intends autonomous driving directly goes to motion service. So that's the vehicle. And the environment domain, road infrastructure, traffic, atmosphere, you kind of get what I'm talking about here. And then you have software update, gateway, diagnostics, and configuration flow. So that's the idea. And one of the key is when you design these APIs, this is just one example, but like this traffic service here has a class like a moving object. Any set of camera data or LiDAR point cloud. Because from application point of view, I don't care how sensor-wise the data is collected. I don't care it's a visual data. I don't care it's a point cloud. I don't even care where the point cloud comes from, either from camera or live data. See, so that's, but you can come up with this kind of approach in defining API because when you start from top down, or if you start from the bottom up, you always have to, okay, I have this camera, I have this light, okay, let's abstract this. Then it's difficult to arrive at this. So, so that's the whole approach of this top-down approach with DBE. So the picture trace diagram I show when I put the DBE in would look like this, basically putting all those services in the previous slide onto this service tray. Okay. Okay, so much about non-automated domain modeling. Then I'd like to talk a little bit about decoupling. So obviously the key strategy to encapsulate the difficult and complex stuff underneath the platform API. Because one of the difficulty to realize programmable code is that one thing is about safety. And to achieve safety, you need to understand real-time system. And a car is a very complex distributed real-time system. And that's a lot of science actually to have a really reliable and deterministic behavior in this complex system. And even though many automotive guys have struggled, I must say. Well now, if you let any application programmer to deal with it, good luck, right? I mean, there's no way it's going to be realized. It's going to take 2 years to develop application, which is not actually. So we need to encapsulate that underneath the platform. And that decoupling is necessary. Also from a safety and security point of view, those has to be underneath the platform, assured underneath the platform, not by the application. And also for the hardware specifics, and I'm talking about not just computer hardware, but also mechanical hardware as well, like sensors, actuators, powertrains, all these mechanical hardware as well. We need to decouple that from the interface. One example, looking at mission critical, not mission critical, if I put in the figure, it would look like this. On the classic platform side, like I said, I wouldn't see not much change from a logical perspective, although physical implementation could change and would change probably. It would be like QM to HUD. On the adaptive side, the platform itself would be mostly HUD, would be bracket D, and application, hopefully mostly QM. The reason I say mostly is that some of them may be HUD, but mostly it should be QM. This is how the electrical different RE architecture could be encapsulated with this approach. This is not something new here. Basically what I'm saying here is use AutoZone platform's approach and enable the service-oriented architecture. AutoZone already have many abstractions for different communication and stuff. Although many of the Japanese OEMs haven't really utilized the AutoZone to that extent, because like for example, RT is not well used, but if you don't use RT, well, you still have the platform to begin with. So that's a, we still have a big challenge, but AutoZone already provide those functionalities. Now, open standards. Well, open standards is important to make technology accessible because it's open. But that's not the only reason. The reason that we want to make it available is because we want to create an ecosystem. Because no one single company, even the biggest automotive company in the world, will not be able to do all these SDV by themselves alone. So we need to collaborate somehow. And open standard will help. The other important perspective is that because we do automotive, our lives of our customers is on danger if our vehicle doesn't operate correctly, right? So then we are prone to lawsuits. We owe to the society of how single company can do those responsibilities, take those responsibilities. They cannot. The society needs to acknowledge, okay, this is the state of the art. This is what all the experts in the industry agree. Not this company, A or B. We agree this is the best approach. That's what the open standard does. And we need that to save the company from these responsibilities. So actually, to master, to own the responsibility, actually you need to partner. So that's the idea. So then this is really important in order to do that. And with the open standard, this is one example how you can have access, because this platform, not only the application will be jointly developed in one way or another. And with the open interface, standardized interface of these services, the interface needs to, of course, needs to remain the same. But implementation or any hardware that's used directly or indirectly by the service could be different. Because API still remain the same. Because you're decoupling these hardware, computer hardware and mechanical hardware. So if you're a hardware vendor or a mechanical hardware vendor, you came up with a new generation of sensors that's not available today, you could actually enable better quality of services of traffic service, for example, with your own hardware and enable into this platform. You can replace the service that's supporting legacy sensors with your own new sensors. But still, the overall logical architecture does not change. The API will not change. So that's the one example. This is, I'm not going into all the details, but it is like 3 major approaches to realize the business. Because this is, well, will be based on the, because it's open standard, it will be based on the open close principle, right? You guys probably know this. And basically, first one on the left is the quality of service differentiation. It's just like the example that I gave to you. We define the same service interface, but you could have, let's say you're good with algorithm, and you could come up with a very efficient and very high precision behavior driver model. You have that kind of technologies, and you could replace. But the API remains the same, but the quality of service, how nicely the vehicle would follow the application command to move would be smooth, for example. That's the differentiation quality of services. The one in the center is that, well, this is a very easy one. The original features, the original applications, you come up with your own application. Like, for example, smart valet parking services. So when I say smart valet parking services, I'm not talking about this application is doing all the data stuff. No, that's done by platform. But this service have a good data source on the cloud side, for example, and know what kind of preferences this driver has, and all the data, current real-time data of the congestion of different parking in the particular area, then came up with a great recommendation to where to park for this particular person. And that's the competence of the service provider. But he's not never automotive guy. He doesn't know functional safety, but he wants to move the car. Yeah. So that's one differentiation. The one on the right-hand side is the original hardware scenario, which is basically what I already described previously. And finally, democratization. Well, this is about enabling anyone to program a car. But actually, what I said here, not just enabling it, but it's important to make it enable them on the democratic managed capabilities. And this one here, the capability allowed for the application shall be controlled by the vehicle user based on the OEM control design, and this is the key, I think. This is a story about iOS, and this is actually a pretty wide article, I think, like 2011. So they're talking about iOS 2.2 or 3. But what it's talking about is that, because I bought the iPhone 3GS, and I'm using iPhone ever since. I also, from a professional career, I worked on Android. We ported Android back 10 years ago to our operating system. And so I know what Android can do. In the early days of iOS, you couldn't even, as an application, you couldn't even access a file system. You then sure know there's a file system in it, but there's no such API. There's many such kind of features in the iOS, especially in the early stages. That must be there, but it's not available. With Android, you could do everything. You could even create a new platform API yourself. But you know what that created? You know, there's a lot of mess for the Android app market. There's many silly applications out there. Something doesn't work, something is hacked, and all those stuff. While the Apple slowly enabled these capabilities to the application, so it's controlled from both business and technical strategy point of view. So it will be important for the SDV for the vehicle manufacturer how to control these capabilities and how to deploy within the lowering the bar of access to the product will be one of the key for success, both business technical. So finally, people talk about unacceptable phrase, smartphone warriors. This is from a quote from TT-Tech. Nothing, against TT-Tech, of course not. But a point that I want to raise here, I disagree with this. I disagree with this. Well, it's not smartphone warriors. It's not smartphone at all. It's such a complex real-time system. But in the end, if you look at all these things that I talked about today, it's actually smart on the wheels. So, of course, we need safety and stuff, but there's a lot common there. And today I talked about mostly up here only, but there's a lot of innovation need to come from both from two-chain process, like Jeff talked about simulation and two chains, like a lower layer from the METI, Ministry of Economics industry talked this morning about the Astra chiplet associates. Well, for sure these changes, new generations, probably new operating system architecture would be indeed, that's something we also do. So a lot of things will happen. So last note that I would like to make is that because our industry is basically being asked the question, to be or not to be, die or not to die. So, so it's a question of will we work together or die slowly? We have all these geographical issues. So I'm so glad to see many people across different countries joining here, because I truly believe in open standards. Actually, it would save not only the industry, but maybe the whole planet, whole human race. Nobody will win in the end. This is my personal opinion, not company's opinion. Nobody will win if we just continue and strive in geopolitical games. We have to work together. So that's, and I believe, AutoZ is one of the few associations that we can do exactly that. Okay, thank you, that's it.